Okay, so here's the last one. We'll do.
Okay, we are now in the final round of the competition. The winner of this round will be the 2009
so I guess he won the
champion.
semifinals with that
The
question.
two students who will be competing for this honor are our number 3 seed, Bobby Shen from Texas, and the number 1 seed, David Yang from California.
Okay. So we'll do the first question from the finals, and that'll be our last one. Okay. Let's see what it is.
Before we get started, David, if I could have you test your buzzer, please. Very good. Bobby, if you could test your buzzer. All right. You guys ready? Yes?
Yeah.
All right. Very good. Okay, the first question of the finals is, what is the area in square units of a parallelogram having diagonals which measure 5 units and 8 units and which form a 45-degree angle with each other?
Wow.
Bobby.
20 root 2.
Sorry, that is not the correct answer.
Ooh, you got it wrong.
Which form a 45-degree angle with each other. Express your answer in simplest radical form.
So this one must be really challenging.
David.
10 root 2.
10 root 2 is the correct answer.
All right. Let's see if we can make sense out of this problem. And let's just remember that the right answer they said is 10 times the square root of 2.
Okay.
So what do we got going on here?
So we have a parallelogram with diagonals 5 and 8,
Okay.
and they make a 45-degree angle when they cross.
All right. So parallelogram with diagonals 5 and 8. I'm not sure I drew this very well. Okay. I'll tell you what. Sorry. Let me draw a parallelogram first. Okay, so here's the short diagonal, and there's the long diagonal. Okay, and we know they make a 45-degree angle. Okay. And what are we trying to figure out here?
It's the area
Okay.
of the parallelogram.
Alright, so this was, the short diagonal here was 5.
Long
Long
diagonal
diagonal was 8. And, one guy got this one wrong, and the other guy definitely took his time on it. Alright, so what do we want to do here?
Well, how do you find the area of a parallelogram?
Yeah, good question.
Well,
how do you do that?
I think it's base times height.
Though I think I see another way to do it if you didn't know how to find the area of a parallelogram.
Okay. What's your idea?
So you could chop off these, if you see these triangles here, you could chop them off
Okay.
and find the area of those plus this rectangle left over.
Oh, interesting. Okay.
And if you imagine this diagonal would go over here, so that would cross.
I'm going to try to draw a better picture. Alright, so here's the 8,
There's the 5.
and there's the 5, and then we got a 45-degree angle here. Alright, so what's going on? So you're saying,
We could
Go
chop off these triangles
alright,
and find the area of those triangles plus this rectangle.
okay.
So if these measures, well, we could also find the area of these triangles in the middle.
Okay,
Well, I see a way to make it easier.
alright.
So if we move this triangle over to here, so
Okay.
those triangles are actually the same size.
So we form something like
a rectangle
that.
We form a rectangle, yeah.
with diagonal 8. Well,
I'm
maybe
not sure.
not quite diagonal.
Because the diagonal of the rectangle is going to go from there to there.
But how would we find the side lengths?
Yeah. How do we find the side lengths of this rectangle? This is definitely a challenging question.
It's a parallelogram with diagonals of 5 and 8.
Yeah. And they make a 45-degree angle when they intersect with each other.
Well, we could use. Well, we don't know the base and the height of.
No, we don't know the base and the height. That's the tricky part.
We do have some similar triangles here,
Yeah?
but we don't know anything about them really.
We don't know any of these side lengths.
But do the diagonals of a parallelogram bisect each other?
Oh, what do you think?
Well, yeah, I think so because the side lengths, this side length is equal to this side length.
Okay, so there's some symmetry in a parallelogram.
But if we could figure out what this angle was, then we could figure out if this triangle was a right triangle or not.
Okay.
Well, you mean this triangle if it's a right triangle?
No, this triangle.
Okay, so we've gone for 6 minutes. I'm just going to pause it and start more.
Alright.